Hi everyone. Welcome to your first lecture here for 1195, and it's a really important one. A lot of the concepts, or one main concept, Newell's model, that we covered today, we're going to be using the whole semester. So it's something that goes to pretty much every unit, and we definitely end pulling all together everything we've learned from the course using Newell's model. But I also want to use this lecture to try to give you a bit of a perspective or lens to which you should be approaching all the information in the semester with. So without further ado, I like to start here with this photo. I think it says a lot about this course and where we're heading with it. So when we consider motor development, there's a lot of different aspects that go into the way we move and also how we move across the age spectrum. So ultimately, we can start identifying things just intuitively in this photo that we can see that are different between our two different movers here in this photo, right? We have a younger and an older individual. One is using some walking poles to help them walk or jog quickly. The other is not, and there's lots of factors in and around that. There's the path they're walking on, which will also influence the way they move. And so ultimately we can sum up what is motor development in this great quote. And we're actually going to be looking at this quote in two different segments. So the components in this are really important to know. So motor development refers to the continuous age-related process of change and movement. So that's one component. We'll look at that first, as well as the interacting constraints in the individual, the environment, and the task that drive those changes. So we'll split this quote kind of into two. This definition is really important to know. Make a cue card of it, add it into your study deck, make sure it gets in there and know it word for word, because this is the course that you're studying. This is explains pretty much the whole process and what motor development is, okay? So again, we're going to take a peek at defining motor development, what it is and is not, and kind of define some of these terms as far as age-related processes, okay? So motor development or motor learning. A lot of the times people or students and sometimes even academics have troubles separating the two. So motor development is the motor abilities, and motor just means moving, right? So or moving development or moving learning. So motor development is the movement abilities related to age or development. So very specific to age or development, whereas motor learning can happen through practice or experience, but is a little bit more confined in time. And that's ultimately the big test between motor development or motor learning. Is when we look at development, it's in the matter of months or years typically, whereas motor learning is more like weeks or months, okay? So development is the continuous process of change in functional capacity. So the capacity functionally to move, related but not dependent on aging. So what that means is, and again, this is just expanding on the quote that we gave you a couple of slides ago. So to say someone is aging does not mean necessarily they're developing. So it's not dependent, but it's related. As we get older, we can think back to that first slide where the older gentleman's walking with the poles. That's related to the age and age-related processes of getting older and having neurological or musculoskeletal changes in the body. But it's not dependent. It's not a prerequisite, okay? And typically this development happens in an orderly and irreversible manner. So for example, once we get to a certain point of development, we can't undo it. So that's a really good thing to keep in mind as well. That'll come up next unit for sure. That's a really good illustration of that. So let's clarify a little bit. I'll give examples. If you want to pause and read each of these quotes in full, by all means, go ahead, but I'll just give brief definitions or examples. So Physical growth, that's literally the physical growing that we do. So getting taller is a great example of that. So it typically has to do with our body mass or our size. And again, if you think about the definition we just covered, where it's irreversible and orderly, yeah, as we get taller, we get taller. Now, we don't really necessarily have our limbs shrink, for example, as we're getting older, but regardless, the process is irreversible once we start growing up. Right? Physiological maturation, so that's the biological things that occur more at the cellular level. So, for example, to get very biology-based, our DNA, as we get older, has these little buffer zones on either end called telomeres. And as we get older, the telomeres get shorter and shorter. Okay, so that's on a cellular level at which we can physiologically mature. Another maybe easier, more tangible example would be something like adolescence, right? So we biologically have our hormones change in our bodies, so that's a physiological maturation. And aging, last but not least, I will read this quote because it's very to the point, I find. So aging is the process occurring with the passage of time. It leads to the loss of adaptability or full function and eventually to death. So it's a very matter-of-fact definition, but I think it gets the point across. Okay, great. So one of the big ways, and I've already alluded to this, how can we tell whether it's motor learning or motor development? Well, typically it's the way we look at and research these two things. So we have longitudinal research, which is a long period of time. Okay, so we look at that individual or group of individuals and kind of track them over time. Then there's cross-sectional studies, which essentially is a picture of a single point in time of a group or individual. And we use this in motor development. Why? Because motor learning typically happens on a short period of time and a short scale. So again, weeks or months. A lot of motor learning has to do with 6-week, 8-week, maybe, if you're stretching it, a 12-week intervention exercise or learning program, and then you measure the outcomes over maybe like 6 months and a year later. But you don't actually do your learning intervention for that long. Development, on the other hand, if we're trying to see how people develop through toddlerhood and into childhood, well, you're talking about tens of years at a time, really. How does someone develop their motor capacity from childhood into young adulthood? Well, that's 15 years, Or what about young adulthood into older adulthood or senior? That's tens and tens, that's multiple decades, right? So what does this look like, these two? Well, a longitudinal study, again, if you're 10, 20, 40, 50, 60 years old, I realize I skipped 30, it's for purpose. So, we have the same group and we just follow them decade to decade. Whereas cross-sectional, we study one group maybe when they're 10. And if we wanted to, at that same year, we can look at 20-year-olds. So right now, if we were holding this study, we could look at a group of 10-year-olds, a group of 20-year-olds, 40, 50, 60-year-olds. They'd all be different people in each group, but we could do it all right now because we're just taking a quick snapshot, a quick photo of that. And again, longitudinal is the exact same group. We'd have to wait 10, 20, 30, 40, 50, 60 years to actually measure that same group all the way across. So we couldn't hold a longitudinal study today and be done with it. We'd literally have to track these people for decades. Okay, so that's the difference between the two. And that's an easy way to try to figure out whether something's learning or development. Development needs these really long-term studies formats. Okay. So an activity, you can pause and go back and kind of review the materials right now on your own. I'm going to zip forward a little quickly. Go ahead and pick a sport or a daily activity, and then based on that activity, try to come up with an example of what in that activity would be physical growth, maturation, aging, motor learning, and motor development. Now, obviously, the examples you're going to pick will be very different. I'll give you maybe a brief example of some as we go forward. just after, and you can kind of compare. But when we do these activities in either class or here online, definitely stop and take the time to do it. I really want to try to highlight these points for you to learn for, say, quizzes, but also they're really good points to highlight and try to ingrain information. Plus, it's fun just to do something and be active rather than just being spoken to, right, in a lecture format. So again, I'll give you a little quick moment to pause. Good, hopefully you pause. And so examples of physical growth, I gave one while we were giving the lecture, but a physical growth aspect would be post-adolescence or adolescence and puberty and growing in physical height. Physiological maturation, I could use that same example. Aging would be something that, again, is a bit more related to the process leading towards death. So we can think an older adult in this example as far as daily activity, to use that aspect rather than just life. We would say, someone whose physiological state, so their let's say knees are starting to get a little bit more painful with age. They're deteriorating due to osteoarthritis, and therefore their daily activities would be affected by aging because they couldn't move as readily. Motor learning, well, we can think back to sports when we're being coached, any sport, and essentially motor learning occurs within a practice. Maybe someone's trying to teach you how to do a corner kick in soccer, so you can learn how to do that in a relatively short period of time. Motor development, again, as far as sports or daily activity in life, something would be maybe like walking. So a toddler learning a daily activity of walking. Okay, great. So moving forward. So we looked at this first part of this definition. Now we're going to look more at the second part here. So we're going to look at what constraints are in individual, environmental, and task sense. And what does that mean? Because that's a bit of a weird kind of statement to say without knowing this. So this is Newell's model. This is the thing that we will constantly be returning to. So get very familiar with this as early on as possible. Really try to understand it. So let me explain what this represents a little bit. Okay, so there's kind of a bit going on here, so we'll just look at it piece by piece. So if you remember our definition, it spoke about three things called constraints. So an individual, a task, an environmental constraint. So a constraint isn't necessarily something that stops or inhibits movement from happening. And this whole model is explaining movement. How do each of these components interact and relate to one another and affect movement, right? That's what it says back here. What drives these changes on these interacting constraints, okay? So again, let's look at this just piece by piece, and then we'll kind of pull it all together again. So an individual constraint is something, and we're going to go into more details on each of these, something to do with the individual. And so it's how the person doing the moving, how their influences affect the movement. How does that afford or inhibit the capacity for movement? A task constraint we'll learn has to do with more the rules and tools as far as how we do our movements and the task itself that we're trying to achieve. And last but not least, we have the environmental constraint. So anything external to the individual or the person moving. And obviously one influences the other, and which in turn influences the third component, and it's all intertwined. Okay, so let's look at each of these in a bit more detail. If any one of the three constraints change, as I just said, they're all going to change, right? Because they all affect each other. Now, as we develop over time, these interactions between the three, the more that are persistent and the more interactions that occur over and over, that leads to the changes that we see objectively or externally in motor skills. Okay, and it's a really, really powerful model that we use for motor development because it reflects how dynamic motor learning and motor changes are over time. And we'll come back to that concept of dynamic motor patterning, and it considers each of the influences on motor development. A lot of models, as we'll see when we talk about movement models or motor models, doesn't necessarily consider all three of these components in the nature that an ecological model such as this one considers. Okay? So again, a constraint is, and again, we'll just go in and dive into this a little bit more. Constraint is a characteristic of the individual, environment, or task, definitely know those three, that encourages some movements while discouraging others. Okay, so let's explore that a bit more. And we'll look specifically starting at an individual constraint. So again, that's a person's unique physical and mental characteristics that will influence movement. So what does that look like? Well, we can have two types. So under individual, we have structural and functional. Okay, structural constraint is related to body structure. So for example, we have our para-athletes here who are missing upper body limbs, their arms, and so that will affect how they swim. It's pretty wild how that happens. And if you watch that in the Paralympics, some absolutely amazing athletes there. So again, if we consider how the task will change, for example, swimming without arms, that's clearly going to be a constraint and alter the movement. You know, not necessarily impede it, but just for that individual, it's going to alter it. Okay. For functional constraint, that has to do more with the mental capacity of the individual. So things like psychologically speaking, like motivation, mood, attention, and we'll, I just love that photo. Very not motivated. There's a large functional constraint occurring here for this individual. Okay, and typically functional constraints are a bit more transient over time. Okay, so they change pretty quick. Okay, next constraint would be the environmental constraint, and that's like the world around us, how things outside of us influence our movement. Now you might think of some things initially with that, but there's, for example, like temperature. You might think of the weather. That's definitely environmental. Literally, it's the environment. But other things such as the socio-cultural influences weigh heavily as an external factor on or constraint on us. Okay, so they're global properties that exist outside of the body. So globally, culture and society influence us through norms or value systems that occur within those states, and we'll look into that on a whole individual kind of approach, a whole isolated lecture later on in the semester. But some just examples here. Obviously, snow on a soccer game is going to change how we move due to the slickness of the field. Things like gender typing as far as sport participation. You know, I think that's a huge influence that fortunately has been broken down, that barrier and that paradigm in our culture and society over the past decade or so. But obviously there's still prevalence there. Okay? And we'll explore that a bit later. Okay, so societal norms or expectations. Okay, and then last but not least, we look at the task. So it's the goals or rule structure of a particular movement or activity, and that it can include the equipment. Okay, so goal, for example, with tennis is to hit the ball over the net to score a point. Okay, so that would be a goal. Rules, that's the parameters of how you can do it. Okay, so for example, if you want to make a rule in tennis to change it where you have to bounce it on your side as well as the other side's court before you can score a point. So that would change the parameters of how you play that game. And the equipment can be similar to a rule in the sense you can change it to make things more challenging or easier. And if you don't know, if you haven't played tennis, you might not know, but if you grew up playing tennis, you know that you have different types and sizes of balls that have different bounce, are easier to hit because they're larger. And here we have our doggo friend who's showing how good of a task it can achieve through holding so many tennis balls in its mouth. But obviously, if we had some of these larger balls, couldn't hold as many, right? So let's try to look at that. Let's try to look at this and apply it to a runner, okay, on a hot day. And I'll get you to do your own task in a moment with this, so I'll just kind of run through it. But we have our three, like our individual, our task, and our environment going on. So let's say this person's trying to run a marathon. So that would be the task. Okay, the environment is clearly very hot. So this person is needing to cool down. But also the individual seems rather fit, in comparison. And from observable anyway, it looks like they have the body type and build to be successful at a marathon. So that brings physiological adaptations that allow you to do your sport or distance events on a hot day a little bit easier. Okay, so between all these things, they're all interacting and influencing how well or how not well the person can achieve their movements. Okay, if they start fatiguing sooner because of the heat, well, that will change their physiological state, which might change their mental state. If you've ever tried to run really hard on a hot day, maybe while we're experiencing like a heat wave or a heat dome or something like that, any outdoor exercise mentally is very, very demanding, very heavy, right? It's not very motivating or enjoyable because you become uncomfortable. So that would affect the functional constraint that falls under the individual constraint, okay? So hopefully you can kind of see how all those tie together. So now go ahead and you can just, again, pause on your own and just think of a few different examples. You can go back, obviously, in your slides and refer to your notes if you need to, but try to pick out a change that you could make to each of these influences that would affect or change the way someone is walking across campus, and then consider how that change would actually change the movement. So again, go ahead and pause it. I'll give one example after. Okay, so if someone was to have rolled their ankle, okay, so that's an individual structural constraint, maybe functional if there's pain involved, but individually, I've changed the way they move their ankle. They're going to want to favor that ankle. So the result would be, as they're trying to achieve the task of walking across the campus, it's going to make the environment, the distance that they need to cover, the crowds that they need to kind of like navigate through a lot more challenging because they'll be limping. Okay, so that's one example there. There's lots of things that you can come up with for sure. Okay, and then just briefly, and we'll be returning to this at the end of the semester, but atypical and clinical applications of Newell's, this is pretty much how it's done, say in physiotherapy, but in particular, if you look at pediatric physiotherapy, I've had experience in that setting, and I can say that you definitely do. So when you notice someone is starting to atypically motor develop over time, what you can do is modify the environment or the task in order to make it, one, for kids more fun to do, but also at the same time try to allow them to achieve it and motivate them. So you change the functional constraint to be able to achieve these movements and want to move more and encourage the type of movement you want them to practice, okay? So again, just to define atypical development, it just means a different form of development. Sometimes it means advanced, but a lot of the times in clinical situations, you're speaking about a delay, and it usually relates to disability or disease, okay? So here in this photo, we have this girl and physio, and perhaps she's trying to get back extension. The physio's trying to get this girl to work on her back extension. So what can you do? Well, you change the task in a way where this child must go through parts of back extension or times of back extension to roll forward on the stability ball and try to reach for these Disney princesses figurines, right? It's causing reaching, extension, back extension. So we can see how we're changing the task to make it more enjoyable to get the motor outcome that we're looking for. So that's a clinical application of that. Okay, and then the last part for today, as far as going through concepts related to motor development, is the concept of universality and individuality and the paradox between the two. And this will come up a number of times over the course of the semester too, but it helps you figure out exactly where motor development falls within the realm of assessing motor movement. Okay, one of the things that we look at is universality, and that's when we look at the members of a species or group of people, in particular humans, tend to display similar development behaviors or stages of development as over a lifespan, right? So generally speaking, the majority of individuals, the majority of people as humans learn to walk at a certain time frame, a certain point in time. Most individuals of our species learn to, let's say, speak at some point in time. Okay, again, this isn't 100% every single individual, but generally speaking, 95% of the time this holds true. So that's the concept of universality. We can look individually at each person or biological individual inside of a group of people, and they will have differences. So for example, there may be 1 in 100 people or 1 in 10,000 people that don't learn to speak. There might be 1 in 50,000 people that don't learn to walk. Okay, and so because of these things, we can see that individuals within a group don't have the same motor capacities. Okay, and so this is where the paradox lies. So this is where the conflict lies between the two. Is when we're looking at motor development, we really are speaking typically about the universality of how movement occurs across or develops across the whole species. Conversely, we acknowledge that individuals have differences. That in and of the Newell's model, there's an individual constraint that causes movement to differ between people just inherently. So while this paradox might seem a little confusing, is really looking at how, when we're speaking about motor development, we're saying, yes, universally, people walk by around this time frame. Universally, people end up aging and losing function around this time period, right? But ultimately, the individuals, we know they exist within the groups. You can just look at this group of kids throwing balls. Each of them are doing different ways. Are each of them doing it as proficiently as each other? No, there is individual difference. But again, when we're talking about motor development, we're generally looking at the universality of all kids of 6 years of age are typically able to throw a ball up in the air in some capacity. Okay. So that's it for today, for this lecture. And yeah, you'll have a couple more out, and hopefully this was a good starting point. Again, I highly suggest you get very familiar with Newell's model, and yeah, that's it for now.